it says homework B, but this is actually homework D. Answers. Oh, we did this. Homework D. Answer to the graphing is right there. And this homework D key is also up on Blackboard. Okay? All right. Okay, so last time we talked about solving systems algebraically using a method called substitution. So today we're also going to solve algebraically, but we're going to use a different method, and it's called elimination. Okay? So with this method, it's really important that you line up all of your like terms. Okay, so all the x's line up, all the y's line up, and all your numbers line up, that sort of thing. Okay? So here's what we need to do. Number one, we're going to choose a variable that we basically want to eliminate from both of our equations. They have to have the same number in front, the coefficient, right? But one has to be a positive and the other one has to be a negative. And here, for number 2, they have to have the same coefficient. You're basically looking for the LCM, the least common multiple, okay? And I'll go into that when we get to a problem that I'll show you a calculator trick, all right? So I'm going to look at my equations here, see how my x's are lined up. And then you see how my y's are lined up, and then my numbers are lined up, right? So this one's good to go. Now, we need to choose a variable from both equations. Like we could choose the x's or we could choose the y's. Which one do you guys want to do? X? Okay. So let's look at our x's. All right. So I have 2x. Wait, what's the number in front of this y? The second one. X. I mean, not y. I'm sorry. Hold on. So on top, I have 2x. On the bottom, what number? 1, right? So I have 2 and 1. So they both have to have the same number in the front, and one has to be positive and one has to be negative, right? So since this one's 2x, you know what I'm going to do? I'm going to make this bottom one a negative 2x, okay? In order to make this bottom one a negative 2x, though, I need to multiply it by negative 2, all right? But you guys know in math, we can't just multiply the one thing in the equation. If I want to change that to a negative 2x,
you have to multiply 3 and 13.
I have to multiply everything, good. So we're going to distribute it to everyone, all right? So here's what's going to happen. The first one doesn't change. So I'm going to rewrite the first one. 2x plus y equals 1. Okay? First one did not change. However, the second one, what is negative 2 times x?
Negative 4.
Good. What's negative 2 times 3y?
Negative 6.
Negative 6y equals, what's negative 2 times 13? Negative 26. All right? So guys, do you see what happened here? I have 2x and I have a negative 2x. I did it. They have the same number. One's positive and one's negative. Yeah? So after you do that, what you need to do is you need to add the two equations. So then I'm going to do plus, draw a line. Let's just add everything down. All right? What is 2x plus a negative 2x?
Negative 4.
What's 2 plus a negative 2? 0, or 2 minus 2.
Oh, it's addition.
Right?
Yeah.
So it got eliminated. You see, the elimination method. It eliminated the variable that we fixed. Does that make sense? But then what is this? 1y plus a negative 6y. What's 1 plus a negative 6 or 1 minus 6? Negative 5y equals, what's 1 plus a negative 26?
25.
Negative 25. All right. Look at that. We can solve for one of the variables, yes, because all we have left is the y. We can solve for the y. How do you solve for the y here? Good. Divide by negative 5. So y equals?
5.
Good. Okay? So now, look at step 5. What does that say? Take that and what?
Plug it into one of the original equations to solve.
Good. We found y equals 5, guys. Now it's the same as what we did in substitution. Take it, plug it into one of your original equations. Pick the easier looking one or the shorter one, right? And then you can solve for x. Okay? Which one should we plug it into? The first one or the second one?
First one.
Okay, let's do the first one. So the first one is 2x plus y equals 1, right? But I'm going to plug in y equals 5. Okay, so then it becomes 2x plus 5 equals 1. Right? So then now, subtract the 5. So then I have 2x equals negative 4. Now what?
So.
Yeah, divide by 2. So then x equals what? Negative 2. Good. All right. Remember, guys, you can't just leave it like this. Give me the answer as an ordered pair. Okay? So x comma y. What number comes first?
2.
Negative 2 comma 5. There you go. And so if we were to graph these two systems, like we made them both equal to y because they're both lines, and we graphed it, then negative 2, 5 would be the intersection. Okay? Isn't this fun? Huh? Did you say no?
I didn't say.
Alright, let's try the next one then. Maybe this one will change your mind. Okay. So it says find the intersection point or points using elimination. Alright, so here's my other thing, guys. I want to make sure that my x's are lined up and that my y's are lined up and everything else, not numbers, right? What you're trying to do, basically, is you're finding the LCM, right? The best thing to do is choose the variable that has a 1. Because those are the easier ones to kind of fix, okay? Like if you look at your x's, what are the numbers that are in front of the x's right now? 2 and 3, right? They're not the same. You're going to have to fix both of them, right? But look at your y's. What are the numbers in front of the y's? 1 and 2, okay? 1 is easy to fix, and you can make it look like the other one, just in the opposite sign. Does that make sense? So if my bottom one is already 2y, then what should I make my top one? Same number, opposite sign. Make it what? What kind of 2? Negative 2, right? Since this one's a positive 2, I want to make the top one a negative 2. So that means I need to multiply it by what?
2.
Negative 2. Right? Because positive 1 times negative 2 is negative 2, right? Okay. All right, so let's distribute for the top one. What's 2x times negative 2? Negative 4x. Right? Here, I can draw these little arrows too. And then minus 2y equals what? No. What's negative 4 times negative 2? We're just distributing. Positive 8. Okay? So we fixed the top equation. Now, do we have to fix the bottom equation? No, because it's going to give me positive 2y, right? So just bring that over. 3x plus 2y equals negative 5. Okay? Now look. Now look at your y's and the number in front of your y's. You have a negative 2y on top and a positive 2y on the bottom.
Cancels out.
Good. Same number, opposite signs, right? All right. So you need to add everything. What's negative 4x plus 3y? Yeah. Negative x or negative 1x, right? And then, Timlin, you said negative 2y plus 2y?
0.
Yeah, that gets eliminated. And it should, because that's the one that I fixed, right? Equals, what's 8 plus a negative 5? 3. Alright, so I realize it says negative x equals 3, but do we need variables as negatives?
Square root.
Oh, no, not square root. Not square root. How do I make this?
Oh, yeah,
Divide. Good. By negative 1. So then this becomes x equals negative 3. Alright. Alright, so I found x. Now I need to find y. And that means I need to take my x equals negative 3 and plug it into one of the original equations. Which one do you want to plug it into? The first one or the second one? First one? Okay. So let's plug that into 2x plus y equals negative 4. But this x equals negative 3, that's going to go in here, right? 2 times negative 3 plus y equals negative 4. What is 2 times negative 3?
Negative 6.
Negative 6 plus y equals negative 4. Now what?
Add 6.
Add the 6. Y equals 2. So, remember, you got to put it in as an ordered pair. What is your x number? Good. Make sure you put negative 3 first, because your x number comes first. What is your y number? 2. So here is your answer. Questions? All right. Let's try the next one. Okay, so this next one, number 3. Uh-oh. Well, first off, are they all lined up? The x's, and then the y's, and then the numbers, they're all lined up? X's, y's, equals a number? Yeah, they're good. They're a little bit crooked, but they're good, right? So here's the thing. Do you guys see a simple x or a simple y with a 1 in front of it? No, not for this one, right? So I'm going to show you a calculator trick. Some of you guys may be able to get the LCM, but if you can't, you can use this trick, okay? Remember, you're looking for the LCM. And now, think about your x's and think about your y's. We're going to see which one requires like one fix instead of fixing both of the equations. Do you know what I mean? Okay. So tell me, for my x's, what are the numbers that are in front of both of the x's? Okay, so we have 8 and we have negative 16, right? How about the y's? Negative 6 and 7. Okay. You guys see what I'm doing here? No? Okay. So, you know how before we were able to get one that had just a plain old x, right? Or there was another one that had just a plain old y. And we're like, okay, we're going to choose the one that has a plain x or a plain y to get rid of, to fix up, right? But here, we don't have it because they all have numbers in front. Do you agree? Okay. So I know I'm looking for the LCM, the least common multiple. So I'm looking at my x's, and the number in front of my x is 8 and negative 16. 8 and negative 16. Okay? I'm just listing them right now. I didn't do anything yet. And my y's, I have negative 6 and positive 7. Okay? All right. I'm trying to figure out what I need to do to them so that they have the same number in front. Okay? So now, let's go to our calculators. All right? To get the LCM, it's in the same place as your GCD. Go to math, number. Do you see LCM? Yeah, the 8th one down, right? Math, number, LCM. So remember, we can't put negatives in this guy, and we can only do 2 at a time, which is perfect. Let's do our x's. 8, comma, 16. Yeah? Oh, what's the LCM for that? 16. Oh, you know what? That's nice. Because then this one's already a negative 16, right? So that one would be easy to fix. Because we already have a negative there, I could just make the 8 become a positive 16. Does that make sense? But just in case, guys, find the LCM of 6 and 7, please. Let's just try that for practice. So for 6 and 7, we get 42. All right? So let's think about this. Guys, we want to go with the x's because their LCM is 16. And look, I already have a negative 16, right? So the only one I would have to fix is this top one because I would have to multiply it by what to get a positive 16? 2, right? Because what's 16 divided by 8? 2, right? But if I were to do the y's, oh no, then I have to fix up both of them, don't I? Right? So we don't want to do that. Let's go with the x's, okay? So with the x's here, okay, we said leave the negative 16x, and we're going to make the top one become a positive 16 by multiplying everything by 2. All right? So I'm going to write it below, right here. What is 8x times 2? Good. 16x. What's negative 6y times 2? Negative 12y equals, what's negative 20 times 2? Good, negative 40. Guys, do we have to do anything to the bottom equation? No, so let's just copy that over. Remember, we like to line everything up. Okay? And then now, look at that. My x's, they have the same number. One's positive and one's negative, yes? So now, once we get that, we need to add the 2 together. Add everything. What is 16x plus a negative 16x? 0. Cancels. It should get eliminated. That's the one we fixed. What is negative 12y plus 7y?
Negative 5.
You got that? Okay, good. Negative 5y equals what?
Yeah, negative 10.
Good. Abner? So then now to solve for y, I need to divide by negative 5. So then I have y equals 2. Perfect. I solved for y, right, Cindy? Which one do you want to plug it into to solve for x? We got to plug it into one of the original equations. Second one? Sure. Let's plug it into the second one then. So the second one is negative 16x plus 7y equals 30. Right? I'm going to plug in y equals 2. So negative 16x plus 7 y. Instead of that y, I put in 2. What's 7 times 2? 14. So negative 16x plus 14 equals 30. Subtract the 14. Negative 16x equals 16. And then divide by negative 16. So x equals negative 1. Yes?
Yeah.
You guys are doing such a great job. Thank you. What number comes first in my little ordered pair? Good. Negative 1, comma 2. All right. How does this feel? You guys like it?
Yeah.
Yeah? I told you it was going to be so much fun. It's my favorite. Right, Abner? Excited? 2 thumbs up. Okay, so let's look at number 4. All right. Because it was too easy. All right, and we're in algebra 2. Okay? I want to show you a different type of problem that you might see here. First of all, is everything lined up? We got our y's. Okay. Why does this one look so crazy? I think this one looks a little crazy, this whole system of equations.
Yeah.
Yeah, right?
Because it's like, it has 2 x's and 1 y.
Thank you. It has 2 x's and 1 y. Great. You have a y, you have an x. What is your other x? X squared. Okay. So, you know, like in Sesame Street, you guys all watch Sesame Street? Okay, so you used to, right? Don't they sing that song where it's like one of these is not like the other? Yeah, find the one that doesn't belong. Okay. So here, which one of those is not like the other? Yeah, the y. Because look, the x and the x squared, they're related, right? Because one's an x, the other one also has an x, it's just an x squared, right? So those two are related. The one that is not like the other ones is the y, right? So if you get a situation where you have an x, x squared, and a y, you gotta fix your y, okay? But if you had a situation where you have y, y squared, and an x, then which one do you need to fix up here? The x. Does that make sense? Yeah? Okay. So that was just an example, so I'm going to erase this. But we need to go fix up our y. So, let me look at this y. I have a 1 and I have a 3. I love it. I love when I get just a plain old 1, right? I can make it match the other one. So this one is 3. So the top y, I need to make it be what? Negative 3, right? Same number, but opposite sign, right? Right, Sabrina? Since this one's a positive 3, I need to make the top one become a negative 3, okay? So, I'm going to multiply multiply everything on the top by negative 3. Okay? I know, it's weird. Alright, so let's distribute. Negative 3 times y gives me negative 3y. Negative x squared times negative 3 gives me positive 3x squared. Yeah? And this what? Oh my goodness, are you like so far ahead of me? Look at you, Ethan. Okay. Right? The bottom one, I didn't have to do anything to, so I'm just going to bring everything over. Hold that thought for me, Ethan, okay? I'm going to have you explain that. And then if I look, my y's now have the same number and opposite signs, right? So I see Kevin, I think Kevin realized what's happening too, right? You see? Oh my goodness, when I go to add, Ethan said it. What happens to the y's? Cancels, which it should, because that's the one you fixed. You want to eliminate. Wait a minute, what happens to the 3x squared plus a negative 3x squared?
They cancel too.
Oh my goodness, what about the next one?
They cancel.
Oh my goodness, so everything on the left-hand side canceled equals, what's negative 12 plus 10? Negative 2? Hold on, so then what's left on the left-hand side? 0, good. If everything canceled out, then you have 0. Wait a minute, does 0 equal negative 2? Good, wow guys, this is false. So this is no solution, good. Good job. No variables were left. What if it was 0 equals 0? What if it was true? Infinite number of solutions. Good job. All right. So this one looked crazy. It was pretty good. All right. So let's look at this one. Are my x's lined up? No. Oh no. My y's aren't. But you know what? Here's the thing. They're both equal to x, right? So how about if we just switch the second equation? We just rewrite it. So I'm going to say the top one, 11x equals 3y plus 36, right? And then the bottom one, I'm just rewriting. I'm not fixing up anything yet. 5x equals, I'm just reading from the right to left, right? Put the y term first, so that's a negative 10y, and then a positive 5. Do you agree? So guys, do you see a plain old x or a plain old y here anywhere? No, they all have numbers.
Yeah.
Okay, so I think this is going to be a situation where we have to do that LCM thing, all right? So the LCM for your x's. Give me the numbers in front of your x's, please.
11 and 5.
Okay, so then give me the numbers in front of your y's. 3 and negative 10. Ooh. I'm going to tell you which one I want to go with.
I got a 55 for that. 11 and 5.
You got 55 for your x's?
Mm-hmm.
Okay. How about for your y's? 30? You know, I want to know what you guys think. Which one should we do so that we save ourselves, I don't know, even like one little step? Should we go with the x's or the y's? The y's? Why, Kevin? It's easier? Well, the 30 is easier? Okay, what else? Yeah. And then, look at that. Yeah. If you look at your x's, they're both positive right now. So you have to make them equal the same number, plus you have to make one of them be a negative, right? But if you look at your y's, well, you have to make them equal the same number, but you already have one that's negative. Do you know what I'm saying? So that's one thing that you can kind of use to your advantage. Does that make sense?
Mm-hmm.
It doesn't matter, really, okay? But that's just something to kind of look out for. All right, so we're going to go with our y's. So, okay, let's set it up over here. 3 times what to give me positive 30? What's 30 divided by 3?
Yeah.
So I need to multiply the top one by 10, right? And then negative 10 times what to give me negative 30? Because this one has to be negative 30, right?
3.
3. So this bottom one, I need to multiply by 3. So there we go. I set it up for myself. The top one, multiply it all by 10. The bottom one, multiply it all by 3. Okay, I want you guys to distribute it, and then I'm going to just write it down here. All right? I'm going to start writing my work up here, and then we'll check, okay? Big numbers.
Yeah.
Yeah. Did you get this?
Yeah.
Yeah? Perfect. So did you double check to see that your y's are fixed now?
Yeah.
Same number, opposite sign? Okay, so then let's add them. Yes? Now what? How am I going to solve for this x? Yeah, divide it by 125 and we get 3. Good. Okay, so now I have 3. Which one did you guys plug it into to solve for y? The first one or the second one? First one? Okay. So it doesn't really matter. Whichever one you plug it into, you should get the same y, right? Yes? Alright, now I'm going to plug in the x. 3. 33 equals 3y plus 36. Subtract that 36. Did we all get this? Y equals negative 1? Super! Now, don't forget to put it in ordered pair. 3 comma negative 1, right? X comma y. Oh my goodness, great job, guys. All right, ready for the next one? Okay, so number 6. Number 6 looks a little bit crazy again. What do we see? Thank you. X squared. Oh no, you can't see that, right? X squared. Can you see this though? X and y. Okay. I have an x squared, I have an x, and I have a y situation. Which one do I need to fix? The y. Good. So let's go and look at everything. Let's make sure everything is lined up, right? All right, let's go see. I can't line up x squared with anything, so skip that, right? Okay. Then I have the x's. Okay, that's good. But wait a minute, look at the next one. It's a number. And the second equation, the next one is a y. So you know what I need to do is I need to flip these. I need to flip these guys, right? So just to make it a little bit neater, okay? If I add the y, then I can move the y to the other side, right? How do I get rid of this 5 and move it to the other side? Subtract the 5. Good. Subtract the 5. I can subtract the 5 over here. Yeah? So then that goes away. I have 4x minus 5 over here. And then on the other side, I have y. Does that make sense? Let's rewrite this. So messy. Okay? The top one I didn't do anything to. I'm just going to rewrite it. Okay? The bottom one, we said there's no x squared, so I'm going to just skip that space. Move over to the 4x. And now we have a minus 5 equals what? Y. And you know, when you switch that negative y equals 5 and you switch them over to the other side, they become opposites, right? Alright, so now I'm going to look at my y's. Because now they're lined up, and now I can fix the y's. Guys, what is the number in front of both of those y's? 1. This is perfect. They both have the same number already. I just need one of them to be negative. Which one do you want to make negative? Which one's shorter? Yeah, that second one, right? So just multiply the whole second one by negative 1. Okay? That way I can make the second y a negative y. Over here, first one I didn't change, so I'm going to write that over. The second one, negative 4x plus 5 equals negative y. Do you agree? Now, double check. Do my y's have the same number, opposite signs? Yes. So now I can add everything. So x squared, there's nothing to add with the x squared, so just bring it down. 2x plus a negative 4x gives me what? Negative 2x. And a negative 8 plus 5 gives me, good, equals, what happens to the y's? Good, 0, because they get eliminated. Oh my goodness, how do I solve for this? Kevin, you know it. I know you don't want to say it, but you know it. Huh? Yes. T-chart, we need a factor. This is AM. I told you guys, factoring is not going away. It's a forever for the rest of the year in Algebra 2 thing. Alright, so here's our AM. You have to factor. Two numbers that multiply to give you negative 3 and adds to give you negative 2. At least 3 is a prime number. What two numbers multiply to give you 3 or negative 3? Negative 3, 1. They add to give you negative 2. Yeah. This is a plain old x squared. Right, Timlin? So that means I can go straight into my double parentheses. I can do x and x, right? You could do it the long way. So what kind of 3 did I have? So minus 3. And what kind of 1? So plus 1. Yeah? Now what? Yep. You make everything equal to 0. My mini equations, right? X. Oh, sorry. Hold on. Let me write it out. X minus 3 equals 0. And x plus 1 equals 0. So x equals what? 3. Stay with me. You guys know this. And x equals negative 1. Right? Hang in there. So this one is pretty cool because now we have 2 x's, right? You need to find the matching y's. So, guys, a big help for you guys is to make sure you keep all of your work organized, okay? Because if you don't, that's when you end up making mistakes. Now, with whatever space you have on the side, draw little boxes like this, and then we're going to put x equals 3 in one box, and x equals negative 1 in the other box, okay? So that we keep it organized. We don't want to flip-flop anything. So x equals 3, we need to plug this in for one of our original equations. Which one do you want to plug it into, the first one or the second one? Yeah, absolutely the second one. So 4x minus y equals 5. All right. You can plug it into that one, or you could plug it into this one, the 4x minus 5 equals y. Doesn't matter. We'll just use the original since that'll kind of keep us consistent. So 4, oh no, I don't like this color. 4 times 3 minus y equals 5. There. Right? 12 minus y equals 5. Now what? Yep. Negative y equals negative 7. But guys, do we like leaving it as negative y? Nope. Gotta divide by negative 1. So y equals 7. So that means when I have 3 as my x, my y is 7. So here's 1. I gotta find the other y for when my x is negative 1, right? So let's do the same thing. Let's plug it into the second equation. 4x minus y equals 5. Plug in x equals negative 1. Add the 4. Now I have negative y equals 9. We don't leave it as negative y. Y equals negative 9. Yes? Oh my goodness, that would be the longest type of problem that you would get. Okay? All right. Okay, so for the next one, guys, do they all line up? No. But, you know, the second one is a y equals. So what I'm going to do is I'm going to subtract the x so I can move it over to the other side, and I can make the top one also y equals. So then this becomes, you know what? I'll keep it consistent with the one below it. Y equals 6 minus x. And this one is 3y equals 18 minus 3x. Yeah? Okay. You can choose which one you want to solve for, x or y. Which one should we do? Should we do y's? Good, both will work, but which one do you want? You want to do the y's? Okay. So Ethan said, let's do the y's. We need to multiply the top one by -3 because the bottom one's already a +3. You guys finish this, please. Try it out. Try it on your own, and then I'll put up my work. All right, so I'm going to put my work up. Should have -3y equals -18 plus 3x. Yes?
Mm-hmm.
The second one, we didn't do anything, so wait a minute. What is going to happen here? All of it. So 0 equals 0. Is that true or false? True, right? 0 does equal 0. So this is true. So this means we have an infinite number of solutions. Yes? Did you guys all get this? Great, good job. All right, then let's look at the next one. You know what? For numbers 8 and 9, these are very important because you'll see problems like this on the SOLs, where they'll say, just identify the y coordinate. Or this one where they'll say, just identify the x coordinate. Okay? In that case, you don't have to find the other variable, just find the one that they're asking you for. Okay? Sometimes you have to find the other one in order to get the one that they're asking you for. But hopefully that's not always the case, and that's just a lot of work, right? You guys want to try both of them? You want to do one? What should we do? I think this one's pretty easy. This one doesn't even have like a square or anything, right? Let's do it. Let's just do all of them, right? Let's do all. It says identify the y coordinate. That means if I want y, I gotta get rid of what? I want the y.
You gotta get rid of x.
You gotta get rid of x. Okay, so we've gotta fix the x. Okay? First off, okay, they're not lined up. I can just rewrite the first one, right? 36 equals, let's do x's first. -11x minus 4y, right? All I did was rewrite it. And the second one, yeah? Oh my goodness, these are big numbers. We said we want to get rid of the x's, right? So that means I need to find the LCM for my x's. Right now, I have -11x, or -11x. I don't need to write the x, do I? -11, and I have -10, yeah? What is the LCM for 11 and 10? 110? 110. Good. So you know one of them has to be a positive and the other one has to be a negative, right? Here, right now they're both negatives. So I mean it doesn't matter. I'll make the first one a positive, I'll make the second one a negative. Is that okay? Alright. So what is positive 110 divided by -11? 10? Okay, so that means the first one is it +10? But positive 110 divided by negative 11? Negative 10. So I need to multiply the top one by negative 10. And then the bottom here, what's negative 110 divided by negative 10? Huh? Remember, this is what we want. We're going to divide it by what's already there. What's negative 110 divided by negative 10? 11. Good. Okay? So that's what we're going to multiply each of them by. The first one, I'm going to multiply by negative 10. And the second one, I'm going to multiply by 11. Gonna be big numbers, guys, but that's okay because you know what? We have calculators. All right, so let's distribute. Yeah? Make sure I do this right. Right? Did I get all my numbers right? So since we're looking for the y's, we're trying to get rid of the x's. Good. Same number, opposite signs. Oh no. Oh. I'm going to add them. What was that? 7? Yeah? Yeah? Am I doing this right? Divided by negative 70. So y equals 2. Do I need to solve for x? No. Just gonna find the y coordinate. So you know what? If you get a problem like this on the SOLs, like here, I'm gonna circle it, but on the SOLs, you may have to click on it for it to like highlight. You know what I'm talking about, right? You guys are taking math SOLs. Good. All right, let's look at this one. Identify the x coordinate. Well, if we want the x, we gotta fix up our y. We want to get rid of the y's. This is nice because it's already solved for y. And look, there's an x squared and there's an x. So we have to solve for y anyway, right? So on top, I have a plain old y, positive. And on the bottom, I have a plain old y, positive. So I need to multiply one of these by what? Negative 1. Which one do you want to multiply by negative? Top? Okay. I mean, it doesn't really matter. It's just, there we go. So let's multiply everything on the top by negative. Okay? Make it just 1 5. So easy. Y equals, oh, what happens after? Square minus 12x plus 13. I guess it all has equals, right? Yes? What do I need to do now? Because I have a negative y and I have a y. Good. Let's add them. That goes away. Oh my goodness. What do I have to do, Ethan? X squared minus 6x plus 8. Just like the other problem we did. I think it was number 5. AM. We have to factor. This is AM. numbers that multiply to give me a positive 8, but adds to give me negative 6 are what? Negative 4, negative 2. Great job. And you know what? This is just a plain old x squared. So I can go straight into my double parentheses. X and x. What kind of two? I mean, what kind of 4?
-4.
Okay, and then what kind of 2?
+2.
All right. How do I solve for these x's?
You have to equal them to 0.
Good. Do your mini equations. X minus 4 equals 0. X minus 2 equals 0. So then x equals 4 here, and x equals 2 over there. Do I need to solve the matching y's?
No.
No, because it said find just the x coordinates. So,
1, 2.
yep. Oh, oops, not that one. There we go. 4 and 2. Yes? Great job, guys. So next class, we're having a review. If you missed next class, please make sure you check Blackboard. Since we're not learning anything new, the expectation is that you're ready to take the test. Okay? If you missed any lessons beforehand, please make sure you talk to me. Try to come and see me sometime this half week. All right? And your homework is a test review. Okay?
What test?